This is section 4.5, and this is the introduction to functions. Before we can define what a function is, we first have to get a few more definitions out of the way. First is a relation. A relation is just a set of ordered pairs. X comma y, points. That's what we also call them. The group of the first coordinates, we call that the domain. Okay, that's just the set of all the x coordinates, or the first coordinate. The range is a set of all the second coordinates, usually thought of as the y's. So let's go ahead and look at an example here. So this is just a finite set of points. So the domain would be the set that just includes these first coordinates. So this 0, 1, 4, -3, 2. The range would be the second coordinate set. 0, 6, -2, 5, -1. Right? So easy peasy, right? So if you have a list of points, the domain are all the x coordinates, the range are the y coordinates. So let's look at another example then. You can see I kind of color coded those for you to show that the red is the domain and the blue is the range. So if we write out these lists, we have the domain is -4, -3, 0, 2, 3. The range, however, is 4, 4, 2, 5, 4. We have this repetition that shows up in the range. If you end up with any repeated values, just omit those. Just scribble those out and don't write them. So we have 4 3 times. Don't write it 3 times. Just write it once. Okay. If you try to write it like this, Hawks is just going to tell you to simplify your answers. Okay. Now let's suppose that instead of giving you a list of points, instead we're going to give you a graph with a bunch of points on it. Well, it's still very similar to the last one. We just have to write the list of points out from here. So like point A is -2, -1. Remember, it's always x, y. So I wrote out the list of those points, and I wrote which ones they were underneath them so you could tell. Then the x coordinates, those are my domain, and those y coordinates are going to be my range. You can see when I wrote those out that my domain, I ended up with 3 repeated, so I just omitted that repetition, just wrote it once. In the range, I ended up with 2 zeros, so I just kind of gently scribbled out one of those zeros. Okay. This one is tougher because I don't have just a finite set of points. I have an infinite set of points. This curve right here is made up of all these points, and it keeps going on forever. It's an infinite number of points, so I can't list these out. So I'm not going to be able to list out the domain and the range. Instead of being this finite list, my domain and my range are going to be intervals. So when you have a graph like this, it's easier to think of the domain, since we know that that's associated with the x coordinate. That one goes from left to right. So it's looking at this graph and figuring out how far to the left does it go? What's the lowest x coordinate and what's the highest x coordinate? And is it continuous in between? For the range, the y value, the range that goes up and down. So that interval is going to be how far down does the graph go and how far up does that graph go. All right, so for the domain, if we're looking at this curve, how far to the left does it go? Well, it's going up, but it's also going to the left infinitely. It just happens to be going up a little bit faster than it's going to the left, but it is going to the left as well. To the right, same thing. It is going up, but it's also going to the right. So it's not like it's going straight up. It's going up and to the right forever. So my domain is the entire interval from -infinity to +infinity. This graph goes infinitely to the left, infinitely to the right, and is connected in between. Now the range is a little different. The range is the down to up. So how far down does this graph go? Well, the lowest point it hits is right here. That's the point 0, 0. So the lowest y value right there is 0. How far up does it go? Well, on both sides it goes up to infinity. And I'm going to use this bracket right here. That bracket tells me that it touches 0. Right? Remember, a parenthesis means it doesn't touch that number. It doesn't include that number. And infinities always get parentheses. Now we can define what it means to be a function. A function is just a set of points, that's a relation, in which each domain element has exactly one corresponding range element. Now, another way of saying this, a more simple way of saying this, is that a function has no repeated x values. Okay, so let's look at some examples and see if they're functions or not. So let's just start off like we did last time with a finite set of individual points. Let's look at those x values. So here are the x values. So I listed out those domain values, those x values. Are any of these repeats? No. So this is a function, right? If it has no repeated x values, it's a function. No repeated x values, it is a function. All right, let's look at this list. You can pause this at any point and work ahead of me if you need, okay? All right, so we're going to look at those domain values, those x values. So if we list out those domain values, we can see that we do have -1 repeated. Because we have a repeated domain value, it doesn't matter if it's repeated twice, 3 times, 4 times, even just one number repeated, boom, not a function. Now, let's look at it in terms of a graph, an infinite number of points. Now, what I did was go ahead and list out some of the points that were on this graph. I know they're kind of small. This point right here is 1, 1, 2, 2, 0, 0, 1, -1, 2, -2. So you can see that if you're looking at this graph right here, those points right there have a repeated x value. They both have an x value of 1. Both of these have an x value of 2. And it's going to keep going. So this is not a function, since there are points that have the same x value. Remember, repeated x's, not a function. Now, this brings up a good point of a shortcut that we can use for determining if something's a function or not. If 2 points on a graph are directly above and below each other, they will have the same x value, and therefore they will make the graph not be a function. Right? So these right here, since they're directly above and below each other, we know they're going to have the same x value. The y value is going to be different, but the x value is going to be the same. This is what's called the vertical line test. Okay? So we say that a graph is that of a function if any vertical line can be drawn on the graph and only touch the graph once. So what that means is if we have this graph, I should be able to draw a vertical line anywhere, and that in those lines individually, so that line right there should only touch the graph one time. That line should only touch the graph once. So any vertical line. Now, sometimes you might see it as like you should be able to take a vertical line and pass it across the graph, and along the way it should only touch the graph at one point at a time. So you may have heard it stated like that. So let's determine if these are graphs of functions or not. So we've got this curve right here. Now, let's look at these vertical lines. That line right there touches the graph once. That line touches the graph once. So far, so good. That line touches the graph once. That line touches the graph once. Is there any vertical line I can draw that will touch this graph more than once? No. So this is a function. All right, let's look at a circle. All right, look, the first vertical line that I drew right there, yep, it touches it at more than one point. So boom, not a function. It doesn't matter if you say, oh, well, if I draw a vertical line right here on that edge, it's only going to touch it once. No. Any vertical line that I draw on this graph should only touch the graph at one point. Some loud thunder. I don't know if you guys can hear that on the recording or not. All right, this one, kind of a little curvy deal here. I drew a bunch of vertical lines. Well, we'll pretend they're vertical. Some of them are a little slopey looking, a little wonky, but just tilt the paper or something. Each one of these only touches the graph 1 point, so it's a function. It's a pretty cool little trick there, right? All right, what about this guy? So if we look at this little curvy deal, in pencil, I drew those lines. Oh, it looks good, right? Those two vertical lines, they only touch it at once. Oh, no. Here it is. Look, there's a vertical line, and it touches this graph at 3 points. Now, does that make it really, really not a function? No, it's just still not a function. Yeah. If any vertical line touches the graph at more than 1 point, not a function. That's because these 3 points, if I were to write out their coordinates, they would have the same x value. All right. So let's determine if this graph right here is a function, and then find the domain and the range. All right, well, this one's similar to that circle that we did. You might remember from such hits as the previous page. We can see that vertical line right there hits it at more than 1 point. That's not a function. The domain and range, remember the domain is the left to right and the range is the up and down. The domain is the x, the range is the y. So looking at this graph here, it's called an ellipse. How far to the left and right does it go? Well, it goes all the way out to -3, and here it goes all the way out to 3. So it's the interval, so all the points on this ellipse right here fall in this interval from -3 to 3. Now the range is the down to up. So how far down does this go? Well, it goes down here to -2. How far up? It goes up to 2. These are the y values. So all the points on this ellipse right here are contained in this interval from -2 to 2. Notice I used brackets because the graph actually touches those points. I would use a parenthesis on infinity or negative infinity, or if I happen to have like a hole in the graph or something else pretty complicated that we don't have to worry about in this course. Okay, next up, look at that guy. Just a nice little line, little y equals mx plus b thing here. If I just draw some vertical lines, all is well. It only touches that line at 1 point at a time. It is a function. Now, I went ahead and wrote the equation for you too. That is just x plus 1, just in case that would help you out a little bit. So Hawks may just give it to you in this form and have you graph it, or it may go ahead and just give you the graph. Now, what is the domain? Well, this graph, how far to the left does it go? Well, it's going down, but it's also going to the left. See, it just keeps going. It's going down and out. Forever to the left. So there's the negative infinity. How far to the right does it go? Well, it's going up, but it's also going to the right. So there's that infinity. The range is the down to up. How far down does it go? Well, infinity. How far up does it go? Positive infinity. Infinity and negative infinity always get parentheses. They're not brackets because they're not numbers that can be included. They are just symbols representing unrestricted growth in the positive or negative direction. All right, then we got this little curvy deal. Now notice this one I put endpoints on there. I didn't put arrows like I did on this one. This one, these arrows indicate that this graph goes on forever in those directions. Here, got some endpoints. That's going to make a difference in my domain and range. It is a function, because if I draw vertical lines, I just kind of lightly drew them on there. They only touch the graph at 1 point at a time. Now, let's talk about the domain and range. Remember, domain left to right, because it's x. Range down to up, because it's y. This point is 4, 3. This point's -5, -2. So the domain, how far to the left does this go? It's not negative infinity because there's not an arrow. It stops back here at -5. Over here it stops at 4. Remember, the interval notation always goes from smallest to largest. So pay close attention to how I color-coded all of this. It is not accidental, right? It's not just to, spruce up my notes or anything. It's very, very intentional that these red things all have to do with domain. The blue all have to do with range. So that's all connected. So the range is how far down the graph goes. So the lowest point it hits is -2, and the highest point it hits is 3. Don't write it as 3, -2. In interval notation, you always have to write smaller, larger. Okay. What about the line x equals -2? This one, remember, is one of those special cases. It's a vertical line where you find -2 on the x-axis and then zoop, draw a line through it. So it's this line right here. Now, the vertical line test is kind of awkward to use on this because it itself is a vertical line. So what I chose to do instead was to just label a whole bunch of points on that line. So if I just label a whole bunch of points, like 2, 1, 0, -1, -2. Oh man, I messed that up pretty bad. I didn't realize I'd put them on the line there. Alright, so here I just picked a bunch of points. Now you may be like, why did I pick those? No good reason, just picked a bunch of points. But look, notice what you can see about all these points. They all have the same x value. So is there any repetition among the x values of this graph? Oh yeah. So this is totally not a function. I mean, like really, really, really not a function. The domain for this, how far to the left does it go? Well, -2. How far to the right does it go? -2. It doesn't deviate from -2, right, on the x-axis. So you can write it as just the single point -2, or you can write it as the interval from -2 to -2. That's an interval containing 1 point. The range, however, is the down to up. Right? So the range, well, how far up does this thing go? Well, it goes up to infinity, it goes down to -infinity. Right, so our domain here, remember, is the left to right, and the range is the down to up. So, a linear function has the form y equals mx plus b. Sound familiar? It should. We write this in function form as f of x equals mx plus b. Right? Now, here's the thing. You may be like, hey, I remember y equals mx plus b. That was the equation of a line. Well, check it out. Linear as in line. Yeah. This is a function whose graph is a line. All we do to write it in like this function notation is replace y with f of x. Now here's the thing. This normally would be multiplication, right? We're used to parentheses being multiplication. It's not multiplication. This is what's called function notation. So this is read f of x, right? What it means is that we're going to take the stuff inside that parenthesis and we're going to substitute it in for x. So let me show you. Easier seen than said here. So if I give you the function f of x equals 3x plus 1 and I ask you to find f of 2. Here's the thing. This is just that, super sexy math notation. It's just whispering sweet nothings into your ear telling you to plug 2 in for x. So you see up here where there's an x, so you're going to put a 2 right there. So it's going to be 3 times 2 plus 1. Order of operations, that's 6 plus 1 is 7. So f of 0, okay, put a 0 right here. 3 times 0 plus 1, 1. -5, all right, let's put a -5 in there. So 3 times -5 plus 1, -14. That's all this is saying to do. So it's not saying to multiply this by 2. It's saying to plug that in to the function for x. Okay. So let's look at another function. They don't have to be called f. We do typically call them f, but they can have any name. So let's call this one g. It's the function x squared minus 2x plus 3. So let's find g of 4. That means I'm going to plug 4 into this function everywhere there's an x. All right, so I get 4 squared minus 2 times 4 plus 3. I put this in parentheses because if this number happened to be a negative, you would want to square the entire thing. You can use your calculator to help you with that computation. Okay. G of negative 1. Okay, so we're going to plug negative 1 into this function everywhere there's an x. This is important. That's parenthesis right there means that you're going to square the 1 and the negative. If you omit that, your answer is going to be wrong because you're not going to end up squaring that negative. Now this one's really weird. G of A. You know, sometimes Hawks throw some weird stuff in there. Well, all that means, whatever's in here, it doesn't matter if it's 4, negative 1, a weird creepy clown face, it doesn't matter. Whatever's inside there, you're just going to replace x with this stuff. So check it out. Now I wrote it with those parentheses and then I just dropped them because I didn't really need them for that. But you get the point, right? Alright, so let's be careful. A lot of students will make a mistake on this. If I ask them for like g of 2, they will assume these parentheses mean multiplication and they will multiply this whole thing by 2. Don't do that. That's the not equals. Instead, g of 2 is telling you to plug 2 into this function for x. All right, so that concludes section 4.5.